Hello students, let me discuss the fractional distillation process. If the difference in the boiling point of the two miscible liquids is less than 25 Kelvin, in that case another method is used. Instead of distillation process, we can use the fractional distillation method. A fractional distillation is a very useful method to separate various components from the petroleum. Petroleum is a very useful product and which is a mixture of and the different fractions which can be separated by the fractional distillation. So let us study now how is fractional distillation done and how is different from distillation process. Okay student, now it is more or less same as that of distillation process. The only difference is here the fractionating column is also used. Now its fractionating column is packed with the glass beads. Now these glass beads, because vapor rise up will condense back and form the liquid. Here also the thermometer is used to keep the temperature constant below the boiling points of that component which has the low boiling point, so that the temperature should be fixed here also students. Heating is continued by a burner. Both alcohol and water will form the small vapors, but the vapors of water will condense back and vapor of alcohol also will condense back and form liquid. But when the temperature is maintained at 70 degrees Celsius, which is the boiling point of alcohol, alcohol will vaporize and the vapors will pass through the condenser. It will pass through the inner tube of the condenser where it will cool and get the flowing water and will condense it, and it collected in the beaker and kept below the condenser, so alcohol can be separated from the water. Water will be left behind. The only thing to be kept in your mind is the temperature should be kept and fixed, should not rise above the 70 degrees Celsius student, which is the boiling point of alcohol. Clear? So this is about the fractional distillation. So now let us discuss some of the examples of the fractional distillation. You must be aware by now that air is a homogeneous mixture of various gases like oxygen, nitrogen, argon, carbon dioxide, water vapor, etc. Now we will discuss how to separate these gases present in air. That is studied that now already you have studied that the gases can be liquefied by applying the pressure by decreasing the temperature. So let us now study how the air can be separated into various gases. Air, first of all, it is filtered to remove the impurities present in some of the dust particle present in this air, so etc. And then by increasing the pressure, if it is compressed to very low volume and then temperature is decreased because the compressed air becomes hot, so it should be cooled. On increasing the pressure and decreasing the temperature, it liquefies, already you learned in previous classes, and forms the liquid air. Now liquid air is then slowly warmed in fractional distillation column. The various gases present in liquid air will then separate according to this boiling point. Now nitrogen has the lowest boiling point. This boiling point is minus 196 degrees Celsius. So it separates out first and then separates argon. which its boiling point is minus 186 degree Celsius, and then oxygen is separate. Last of all, its boiling point is minus 183 degree Celsius. Also, the percentage by volume also now that oxygen is present 20.9%. The by volume of nitrogen is 78.1%. By volume of argon is only the 9% by volume. Also, with the help of a schematic diagram is shown here how separation of gases can take place from liquid air. Now here this is a filter to filtrate out the impurities from air like a dust particle. The filter air is then passed through this pure some water where air is compressed by these pistons at high pressure. Now the compressed air becomes hot, and the hot compressed air is passed through this compartment where this hot air is cooled down by this freezing the cold water. Water is continuously being circulated to cool the air, and now the air has cooled and compressed air is now deposited through the separator. Here from this separator, the solid carbon dioxide, first of all, somewhat in the separator we can observe the solid carbon dioxide is formed because the carbon dioxide solidifies on cooling, it separates. It also called dry ice. The solid carbon dioxide we also called it's a dry ice. It is important component. Then it is used to the things cool. They keep the things cool. And from this separator, then liquid air is passed through this compartment through the jet. From the expansion of jet and liquid air is then formed the gases. Nitrogen gas, the first of all separate and warming air little because it has low boiling point, and then argon separates, and then it is passed through another compartment where the liquid oxygen separates because it highest boiling point than compared to nitrogen and argon. This is how the different gases present in air can be separated by the process of the fractional distillation. Now we will study how to get pure solid from an impure sample. For this, let us perform an activity in the lab and also learn how it can be done. A pure solid can be obtained from the impure mixture by the process of crystallization. Now what is crystallization, students? Have you heard about this one? Crystallization is a process of separating a pure solid in the form of crystals from a solution. So this activity can be performed in our lab by collecting the apparatus takes place. Take the 5 gram of copper sulfate and dissolve it in minimum quantity of water in a china dish. By stirring, filter the copper sulfate solution by the help of funnel and filter paper. If there is any impurities in the solution, it will be left behind on the filter paper. So now this filtered copper sulfate solution should be taken in the china dish and it will heated with the help of a gas burner, and as shown in figure, student. Heating should be continued till some of the liquid is left behind, till a saturated solution is obtained. It is not to be heated for a long time, so that's only the solid is left behind. It has to be heated in such a way that it's a saturated solution is obtained. Now somewhat extinguish the burner, keep the china dish on the table and cover with the filter paper. Leave it for cooling for a day, and next day what will you find? What will you observe? You will find the crystals of this sulfate of formed. So this how the pure copper sulfate can be obtained by crystallization process from the impure sample. A solid also can be separated from mixture by the process of evaporation, but the crystallization is a better technique as compared to the evaporation, student, because some of the compound on heating these are decomposed, so that we cannot get the compound because it has decomposed, and some of the compound it become block on heating, like the somewhat it become churned on heating, like sugar it also become black on heating. Some of the impurities also dissolved in water or any other liquid if it is taken, and those impurities will also crystallize along with the solid and it will contaminate the solid. So crystallization is a better technique, okay, to separate some of the solid particle from the liquid. Clear, student? Let us now discuss some of the very important applications of crystallization. Crystallization is used to obtain pure common salt from the salt obtained from the sea water. Because of the salt obtained from sea water is not pure, it is impure. It contains some other salt also. It is used to obtain pure. So the crystallization process we can use it, and this process is also used to obtain the pure crystals of alum. So these are the various applications of crystallization. Now let us discuss how water can be purified in water plants. Water to supply in various houses from the water plant. First of all, it purifies and then it is sent to the houses. Here, water is stored in the water reservoir and then it is passed into another tank where the solid impurities are allowed to settle down. This is called sedimentation tank, student. So, in the solid impurity, the settle down, then it is sent to the another tank, that is called it's a loading tank. Here the suspended impurities which still remain in the water are made heavy by adding the substances so that these impurities become heavy and they settle down. Then the water is passed through the filtration tank which is packed with fine sand, gravel and cores of the gravel. Then the water is filtered here, and again this filtered water passes through the another tank that is called a chlorination tank, where the chlorine is used to kill the bacteria, and then this water is sent to the houses where it can be used. So this is how water is purified before sending into the various houses. Clear, student? To understand the difference, somewhat this is about how can you separate the mixture from the mixing component from the mixture. Clear? To understand the difference between pure substance and mixture, we should know about the physical change and chemical change. In the previous chapter, you have studied about the physical properties of matter like rigidity, like fluidity, melting point, like color, the density, boiling point, etc. Is it right, student? Now you are all aware about the fact that the water on heating it changes into water vapor. Water, when it is heated, it changes into water vapor, and on cooling it changes into ice. Is it right, student? Now think about it. Is it physical change or a chemical change? Ice is also solid form of water. Water vapor is also a gaseous form of water. Only the physical state has changed. The interconversion of state is a physical change. So let us see what is a physical change. It's a temporary change. Now during a physical change, no new substances formed. Only the physical state is changed. No new substances is formed. Okay, so it is a reversible change. Let us see some more examples like the breaking of a glass, cutting or a tearing of a paper, the glowing of electric bulb when the electric current is passed through the bulb and bulb is glowing. You think about the more physical changes like dissolving the salt in water. And is it the physical change, students? No. New substance is formed. They can get back salt also, and we can also get back the water. So it is a physical change in which it can be reversed. The melting of wax, it is a physical change. Now perform. So think about the more activities like burning of a candle. Now when the candle is burned, the wax is melt. So melting of wax is a physical change. I agree that one. But the candle burns and forms the smoke. That is a chemical change, student. So just now we studied that the interconversion of water, it's a physical change. But when the electric current is passed through the water, it decomposes into hydrogen and oxygen. So already you know, student, what is made up of the two different molecules, hydrogen and oxygen. So now this is a chemical change and not a physical change. The decomposition of water into hydrogen and oxygen. So can you get the candle again after burning? So if you burn a paper, if you get a back paper again, student? Now at home, milk is converted into curd. Can we get milk back from the curd? So curdling of milk is a chemical change. So those are considered as some of the examples of chemical change. So let us see what is a chemical change. A chemical change is a permanent change. Now in this change, a new substance is formed and the change is irreversible. Think about some more examples. Growing of a plant. Okay, a plant is grow a seed to a and the somewhat is seed to a big plant. We can observe daily it can grow and digestion going on inside the body and the respiration is going on inside our body. These are all chemical changes, and when a chemical change occurs, a chemical reaction is also occurs, students. So in this way, a chemical change is also called a chemical reaction. Because a chemical change occur, then a chemical reaction also occur. A new substance are formed. If hydrogen binds in oxygen, it will form water. When water is decomposed by passing electricity, then it decomposes. These are both the examples of a chemical change. Okay, students. So this is about physical change and chemical change. Clear? So this is about your the second lesson is matter around us view. Okay, thank you, students.